Hello and welcome to Dev Radio. I'm excited to be here today with Alex from NASA Space Apps, JD from Elastic, and Naveen from Microsoft. We are sponsoring the NASA Space Apps Hackathon, the local chapters in Chicago, Mountain View, and Toronto. Actually, you might not have known that we are on board in Toronto, Alex. But it's a really awesome hackathon, solving for outer space science. I love science. It shows us what's possible. And today we're going to show you what's possible with a couple cool AI tools. Alex, do you want to go ahead and introduce yourself a little more thoroughly?
Yeah. So I'm Alex. I'm a local lead at for the Chicago event. I got involved a couple of years ago. I think this will be my third year. And so when we started in with this group of leads, we had about 40 people show up the first year. Last year, I think we doubled in size, and then we're hoping to double that again this year, roughly speaking. So we have the largest event in the United States, at least by registrants so far, and so we're looking forward to another year. And I think something that we wanted to show. Should we just jump right in?
Yeah, let's go. Yeah.
So I've kind of served on a little bit more of the technical side. And we call them mentors, so kind of mentoring the students and helping them with, not necessarily students, participants, though in Chicago we've often had a lot of students show up, but kind of helping them just with general tech help, whether that's with coding or configuration or getting set up or kind of ideation or working with data. There's all kinds of things that the participants run into over the course of a hackathon. And one of the really common issues that I've seen over these past couple of years is it's very hard to work with NASA data. The Space Apps Hackathon is very cool in that NASA provides a lot of data, and they provide really interesting challenges to kind of guide your hackathon experience. But just because the data is there doesn't mean it's easy to use. And so this year, we have this partnership with Microsoft and Elastic, and we thought it would be helpful to kind of just put together some more examples, maybe some useful tools to show how to use some of the data, and make it a little bit easier to get started, just working with this type of data. And you mentioned, actually, I wanted to call out that this is NASA Space Apps, and there's a lot of cool space data there. But a lot of the data that's provided is actually Earth data. So geospatial data, imaging data of the Earth. And so there's sort of both of those. And actually what we'll look at today is actually Earth data. And working with some of that. And so I can kind of demonstrate, so with all of the AI stuff that's going on in pop culture and just in general, I thought it would be cool to kind of incorporate that into a tool and kind of have that be available to the participants when they show up, should they want to use it. And so I put together a little MCP server, and a demo application to work with one of the common data sources that I haven't actually looked at the challenges yet this year, though they were just released. I expect this data source to be in there somewhere. So let me figure out how to share my screen here. Okay, can you see this?
Do it one more time. I clicked the wrong place. Folks, bear with me. I've got new tools here. Try sharing one more time, Alex. Perfect. There we go.
Okay, great. So this is a simple Gradio app for anyone that is familiar with that. That is running a simple line graph agent behind the scenes, but it's connecting to an MCP server that I wrote to talk to this app ears data set. So I wanted to actually highlight this. This is a NASA maintained data source for exploring geospatial data. And there's more information in here. We've included a link in the notes here if anyone wants to kind of explore that. But it's very hard to use. At least personally, I found it difficult to use. The APIs are kind of tricky. Querying for geospatial data is kind of tricky, even if it's super user-friendly, it's kind of hard. And so I put together this MCP server that can be used to more easily query this and put together the different types of API calls that need to happen to download the data. And so here's an example, and make sure that I have these right. It's a live demo, so hopefully this works. But let's say we want to know, one of the interesting data sources they have is they have a bunch of data on hyperspectral data and like surface reflectance data. And so we can say, well, can you tell me what kind hyperspectral data is available in app years? And so hopefully this is going to go off, and we can see it use the tool from the MCP server. Unfortunately, it was successful, and hopefully it'll kind of summarize back the available products. This is OpenAI is being slow right now.
Yeah, I remember you said that might be an issue.
Yeah. But I do have the logs going in the background. There are no errors, so. Bear with it for a second. Oh, I see what the issue is. I can see the logs in the background. There are a lot of products, and so it's working through them right now. Here we go. So it's going to summarize some of them. It's pulled out from the list of products, the ones that it thinks are most relevant for hyperspectral data products. And we can ask, I actually copied over some queries that I know work. When working with geospatial data, they offer what they call layers. So these are different, in this case, they're kind of like different bands of hyperspectral data. And so, but they define those as layers. So we might ask, we may not want all layers, figure out which layers are available. And this should be a little bit quicker, hopefully. You can see the tool call again worked successfully. And then once this is finished, we'll be able to kind of say, okay, these are the layers I want. Please go download the data set for me.
How long did it take you to put this together?
It was actually pretty quick. Sort of quick. There's a bit of trial and error. Like I mentioned, the API is a little bit difficult to work with, but the agent development and the MCP stuff was all kind of handled by Copilot.
Cool.
So just kind of working with Copilot and passing in documentation and letting it kind of do its thing, knocked it out reasonably quickly. I think I did it in a weekend.
Yeah, good project.
Not full time, but so we see now these layers came back, and they're all just different surface reflectance for different wavelengths. And so I copied this. I'm not going to type it all in here, but I'm going to ask for every 10th wavelength for it to include that in the data, and also to include data for a bunch of different locations from different types of geographies. So like in the United States, an urban, a rural location, a mountainous location, and then a coastal location. And so I found when I was testing this earlier, I had to tell it to actually use these identifiers instead of these texts, or it would error out. So this is going to go, and the way that the app ears data works is you submit a request for download, and it will trigger that request, and NASA will pull together the data for you to be downloaded later. So it's not quite as instantaneous as might be nice, but that's what we're working with. And so we can see, okay, it created the request, and it submitted the request, and here are the IDs. And I can now go over here and see, should be able to see. Oh, it actually created 2 different requests for me. So I'll have 2 different data sources. And they're queued. We won't wait for them. I've actually downloaded them previously and shared them with JD and Naveen to kind of show how we might use some of that data within the context of Elastic and Microsoft to do some pretty cool things.
Cool.
So I'll hand it off to JD, I think.
Cool. JD, should we, why don't you set up what you're going to show us, and then I'll pull the demo up.
Yeah, sure. Hey, everyone. My name is JD, and I'm a developer advocate at Elastic. A lot of you guys probably know us as Elasticsearch. In my role, I help developers understand kind of how to get the most with the Elastic stack, whether that's search, observability, security, or more recently, AI and agentic workflows. So at Elastic, you kind of bring your data to us, and we give you a bunch of tools to be able to find what's most relevant for you and your agents. Yeah, just for a little context, we're super excited to support NASA space apps and be able to interact with some of the brightest people out there looking to solve some pretty big challenges. We're just looking to be a resource for folks and empower them and bring their solutions to life using Elastic's tools. And I really can't wait to see what people build. So I wasn't as brave as Alex to do the live demo. So Matt is going to play a video for us.
Which this will be awesome, though. I've seen the video. So and if there's any bugs, it's because I don't know how to work the new tools. But hold on, here we go.
All how to get started with Elasticsearch, get your data in there, and show y'all a few features that could be useful. Do a quick demo of our new agent builder for the folks building agentic systems. So first, we'll go over how to sign up for an account. We do offer a 14-day free trial, which would be perfect for the hackathon because you don't need a credit card or any forms of payment. And I took some screenshots here of some of the prompts that you might get. So first, it's going to ask you for your name and your company name. I'll just keep it my name, and we'll just use NASA Hackathon as our company name. Next, we want to click on the Elasticsearch focused instance. And the last thing I want to emphasize is we do want to create an Elastic Cloud serverless instance. Just because some of our newer features or in preview features are only available for serverless. So click the continue button, and it should take a few minutes for that to spin up. So after a few minutes, once you get that serverless instance up and running, you should be greeted with a homepage that looks something like this. We'll go over how to actually get your data into Elasticsearch. So there's a few ways you can do that. You can do it programmatically with a specific language client, or if we want to keep it simple, we can use this upload feature we have here. So just click on upload a file. We're going to select the data set that Alex provided for us. Check over that we have the right type of data. Check over our fields. Click import. And I want you guys to go into the advanced tab. So one thing I want you guys to look at is making sure that all your field types are correct. For example, if you want to do aggregations like find the average of a field, you're going to want to keep that field as a numeric type like double or float to make sure that you can actually run those aggregations. And if you want to take advantage of some of the geospatial features, you do want to coerce our latitude and longitude into a location that's with the type geopoints. And one thing that I do see that we can improve here is the date. It's showing up as a type keyword, but in order to search through different dates, we want to actually make this into a date type. So we're going to change the mapping here. We're going to paste in a date type here with a type date. And you want to make sure that the format that you have here matches the format in the data set. So it shows up as a date type. And if we look over at the ingest pipeline for GeoPoint, we have the field location with the values of latitude and longitude. And Elasticsearch already handled that for us, so that's good. If we want to use the geospatial features, So everything here looks pretty good. We'll give it a name. We'll click import. Once you see all those green checks, you should be good to go. So now we can head over to Discover just to check whether our data was ingested correctly. We can expand one of the documents. It says that our date is the actual date type, so that's good there, and we have the geopoint. And we have these numeric types actually show up as a numeric type. So all good there. And one of the things you can already do is create dashboards and all types of visualizations with Kibana to kind of give you some insight on the data that you have. So we'll click on dashboard, and I created a quick map that plots out the locations of our data points. And if you hover over it, you can see which point it is, the reflectance, the wavelength, and which category. So in this map, the lighter the color of blue, the higher reflectance. And this is for a specific wavelength range. And you could change that here with this range slider. Say we want to see the wavelength between 500 and 800. You can see the colors will change because the average reflectance is going to change. And on the right, we have a simple line chart that shows on the horizontal axis, we have the wavelength, again, determined by our range slider here. And on the vertical axis, we have the average of reflectance, and each line is a different category, like coastal, urban, or mountainous. And again, if you change the range slider, you can see the average reflectance for different categories and for different wavelengths. So I wanted to show off one more tool that could be useful for a lot of folks, especially those that are building some sort of agentic AI app or something with an LLM. That is Elastic's new agent builder. So the agent builder essentially gives you a framework to build agentic systems around your data in Elasticsearch. So in the case you want to connect your agent to your data and be able to use some of Elastic's core search functionalities, like your basic lexical search, vector search, geospatial search, or combine them with hybrid search, Agent Builder simplifies that process for you. For example, for people who want to add some sort of RAG functionality to your agent, this takes care of the retrieval part, helping your agent find the most relevant data for the query you give it. You have a few ways to connect to the Agent Builder. You can expose your tools, either the built-in ones or the custom ones that you build through MCP. You can also build a custom agent and interact with it using the A2A protocol, or you can build and communicate using simple API calls. To get started with Agent Builder, we'll go back to our serverless instance. So the Agent Builder is still a feature in preview, so it's not enabled by default. So all we need to do is go into our developer tools here, run this command, and we'll provide all these commands for you to copy and paste in your resources. Run this command, and you should be able to see Agent Builder enabled true. After you run that, you should actually see this Agents tab within your navigation. So click into that. Here we already provide a chat interface, so you can already start chatting with your data. If we head over to tools, we can see what tools are available for our agents. Here we have some powerful built-in tools that you can already get started using. But in the case that you want to implement specific guardrails or tailored prompts, or maybe you don't want to generate a ESQL prompt for each and every query, you can register your own tools. So we'll click into this one we created. You give it a tool ID. You want to give it a natural language description so the agent will be able to read what it actually does. And in the configuration, you can input your custom ESQL query, as well as the parameters that it'll need. So in our ESQL query, we said that from our index NASA Lite, where the category is matches our parameter, we want to get the average of the reflectance. So once you have that saved, you can see your tool here. You can now expose this tool set by clicking on the MCP config here. This will give you your endpoint. All you need to do is put in that endpoint as well as your credentials, like your API key. And using this, you can add it to your agentic framework or Claude desktop, wherever you can connect an MCP server. So you can also build an entire agent around your data with a specific system prompt by clicking New Agent, enter the agent ID. This is pretty much how you're going to be calling it. The instructions is going to be basically your system prompt, where you can add your guardrails or the workflow you want it to follow, the output you expect it to have. And you can connect to this agent using A2A, or you can just actually make direct API calls. Now, to bring it all together, you can test it either using the built-in chat that we provide here, or plugging it into your agentic framework, or connect to it using something like Claude Desktop. So that's what we're going to demonstrate real quick. We're going to copy this MCP server URL, go into Claude Desktop, click into Manage Connectors, and under developer mode, you can edit this config, add that endpoint as well as your API key, restart Claude Desktop, and everything should show up correctly. Just to check that everything is working correctly, we can see here that our Elastic MCP is turned on and connected. Let's ask it, what are the available tools within the Elastic MCP? All right, so everything seems to be connecting correctly. We have our built-in tools, and we also have the custom tool that we registered ourselves. Now we can ask it a question around our data, like, what is the average reflectance for the coastal category? All right, so it's saying that it wants to use our NASA average reflectance by category tool, which is correct. It's passing in coastal as the parameter for category, so we're going to allow that. Okay, perfect. It says our average reflectance value is for the coastal category is a negative number. This is just due to the data set. I think they use negative numbers to instead of null. So you can either pre-process or pre-filter your data set to not have these negative numbers. So to demonstrate some of the built-in tools, we'll ask it, what is the average reflectance for the coastal category, and filter out the negative values. So it says it's going to use the tool for generating ESQL, which is correct, so we'll allow that. Now it wants to use the built-in tool for executing the ESQL, which is correct. Here we see that from our NASA Light Index, where category is coastal and the reflectance is greater than 0, we want to get the average of reflectance, so that's all good and working there. Awesome, so it says our average reflectance for the coastal category, excluding negative values, is 0.2. And I did check over these numbers, and it was correct. So as we can see here, by using the agent builder, we can provide some pretty powerful search tools to an LLM, giving it some extra context around your specific data set. So thank you all for watching this demo. And next up, I'll pass it off to Naveen.
That's great. What's your favorite part of that, JD? It all comes together. So, oh, you mute.
I think, my favorite part has been so far is like trying to learn about the different data sets that NASA has, and like all these terminologies that I had no idea that what they were initially, and just being able to kind of build your tools around your specific data set, and being able to connect it to like something like Claude Desktop and all of those tools kind of populating. I think that was really cool to see.
Yeah, I'm really excited. The MCP builder and agent builder are super cool. I'm really excited about the A to A protocol. I think that's like totally gonna be taking off. But it's especially cool from the perspective of a hackathon where we may not be building dashboards. They might be useful for data exploration and such, but you can really easily hook that into really any type of workflow that you want to build. If you're building any kind of application or whatever it is that might be being built for Hackathon. Just the flexibility that allows you is really exciting.
Totally.
Before we move on, just logistical thing, that free trial is available to everyone?
Yes. So all you have to do is go to elastic.co, and there should be a button that says sign up for a free trial.
Amazing. And if people are signing up for Space Apps, is there a way to indicate that they're with the Space Apps, the hackathon?
I think we'll have everyone try to list their company under something like NASA Hackathon, see if we could track it that way. Otherwise, I think we might be able to track that internally, so we should be good there.
Great.
Well, you'll just see a huge spike over the next few days, I'm sure. So.
Absolutely.
Naveen.
Hi everyone. Hi Matt.
Ready to show us how to put an app together now?
Yes. So so I'll have something. So first we'll talk about GitHub Copilot, and then we'll go more into that. But just before that, I'll have a quick intro of mine. So this is my second time being a judge at NASA Space Apps at Chicago, and last year I was part of that, and I was doing mentoring as well as judging last year, and this year I'll be continuing to do the same. So apart from that, so I'm a solutions architect at Microsoft in data and AI space, and apart from work, I do a lot of other stuff as well. So I write blogs on AI. So I've written around 50 plus blogs on AI, and I'm an author of a book on MCPs and AutoGen. I'm currently writing a book on MCP, and apart from that, I do contribute a lot to the AI community, and I'm a podcast guest to all AI podcasts as well. So,
hey Naveen, before we go on, could you? Sometimes this platform has a hard time with processing power when you've got the backgrounds on. Mm-hmm. Are you in a place where you could turn off that background? Maybe I think your video would be a little better if we.
Sure.
Just before you get to the actual demo, I want to be sure we've got
definitely
good smooth demo. Well, look, it's a great background. That looks just as good. Yeah.
Yeah. Is this okay?
Yeah.
Yep. Cool. Does that look good?
Yep, looks good. You're a little smoother now. Thank you.
Oh, okay. Thank you. Yeah. So before I get into the demo, so first I'll start with a Copilot, GitHub Copilot, and then I'll quickly show you overview of what you said, like how a custom MCP server can be built against Elasticsearch and then can be used for your future use cases, right? I'll be covering that piece as well. So let me start by sharing my screen, and here we go. Yeah. Hope my screen is visible. So so I got this idea, like create a UI where you can upload your data, CSV file, any CSV NASA data that you download or got as part of Alex MCP server, right? So you have that data, and then you wanted to push it to Elasticsearch. And this dynamic tool, what I have created with the help of GitHub Copilot, will definitely help you do that. And it's just before I go into the things, so this is the app what I have developed. So with the help of GitHub Copilot, and I didn't write a single line of code to complete this app. So if you see this, so this is my initial prompt, and then so I'm just trying to build a quick app with a simple UI. I need to take a CSV file and load it into Elasticsearch. It should automatically take the column names from the first row of my CSV, and I may need to see progress of the load to tell me, like, for example, if I'm uploading millions of document, right? So then I should be able to know what I'm doing. So and it uses OpenAI models if needed, which means for choosing the right data sets and then data types for your data, right? So for your data set. So this will be helpful, and it's just before I go and ask it to do anything, all I want is to create a plan for me, and then let me review the plan first, and then proceed. Right? So I asked the UI to be static so that I can host a static website on Azure, and the API can be a function app. Right? So these are my needs, and then I also told it like we may need a workflow.yaml where I can create a GitHub workflow from where I push my code, and then how it deploys. It just should happen seamlessly. So that's my initial prompt, and then it just created a project plan and with a front end with the HTML, and then the back end with the JS file and CI/CD, and it also gave me some optionals. Right? So all what it does is, so to start with, so it all happened right. So when we talk about GitHub Copilot, right, the day when we started is we have to give in a lot of inputs, and then it gives you the output, or it does analyze your code, and then it gives you the output, and it's your responsibility to copy paste all the data and then make it working, right? So but here with the agent mode in here, I don't know whether it's visible to you. So this agent mode in here, it kind of takes care completely. It will have full control of your app, and it kind of goes back to the file and then make necessary changes, and then it executes of its own, execute your code of its own, and so that's how you see. And for this demo, I have selected Claude Sonnet, and then in fact, yesterday I was trying GPT-5 Codex as well. So and that's also giving me fantastic results. Right? So you can choose your model whichever you want. So and this GitHub Copilot, it's not licensed or anything, so it's just free for it's free with some limits, and you can make use of this for this development. And last year, I still remember a lot of folks having some difficulties making their APIs or web app look beautiful, and then being very successful. Or when you judge a solution, right? So these things plays a additional role, even though they are not directly related, but still the appearance gives you a clear developing. So I recommend to make use of this complete GitHub Copilot feature, and definitely it will save some time. So this complete app I developed within like 10 to 15 minutes, I would say, by giving all this going back and forth. So it just created the plan, and then I approved the plan, and it went ahead and created all the files that's needed for me, and finally it gave some what do you say, it did some back and forth, and then finally I was able to get my output. So let me just quickly show you like how it is working. So again, this data I got from Alex from his MCP server data, and here I have created my Elasticsearch index, and I'm just using this index demo data to push my code. And once you say this, with this progress, you'll see like 348 documents uploaded. Right? So this is how fast your data can be uploaded. And in the same way, it is not just for local. The same way you can create your app for retrieval or plotting the data and showing some good value. So you can do much more than what it is. What you see here. And the second demo, what I have here is like how you could query the data from the Elasticsearch. So let me stop sharing this, and maybe I'll have to share another screen here. So just give me a minute. So this is my second app. What I just built like this morning. So this app is nothing but has two things in it. So it has a MCP server where you can just hook it up with Claude, and then get the same details, same answers what I'm getting here. So it all started by creating a uh, creating a chat with data kind of solution using MCP with Elastic. So if you see this chat console app, it uses the same Elastic data what we have uploaded here. And just before that, I'll just run my app. So when you run this, it just starts my local MCP app where I can ask some questions, and then get the answers from. So just before I do, right, so this will just send it some question, and we'll see how this helps. Right? So Just copy the question. Or otherwise, maybe I'll type this. Sites their peak sites have their peak reflectance, and you kind of so it just generated a query, elastic equal query, and it just for just the token size, I'm just limiting it for 10, but in your use case, you can just open it for all. And here are the data. So here is the result set, and then you can play with it for any type of Q&As. Again, so so it doesn't stop with just creating your application. So you can also have test cases written by this. You can also have apart from test cases, you can have documentation. So this documentation, what you see here, it's completely written by this GPT-5 codex model. So here is it kind of made a architecture diagram for this solution. Like this is a natural language, and then it kind of uses the MCP server and then get the Elastic data, and then it generates a SQL query, and it also make use of OpenAI GPT-5 Nano to generate the query for this. So and also it gives me it makes sure that it's not showing any keys here, and apart from that, it just created this env file for me, and then it shows you how to run and how can you this up with Claude desktop. So again, it also gives me some natural language examples, like these are the questions what you ask against this data, and so yeah, that's it basically. And make use of these tools along with GitHub Copilot, and maybe after this we'll try to push to GitHub Repo, and then you can just use it for your local development. That's it from my side today. Thank you.
JD, I see what you mean about, like, I feel smarter about this data now. Like, I feel like I know more about reflectance. So
Same. But once we get into a different data set, it's starting from zero again.
Totally. I mean, my favorite part of that was making the simple architecture diagram. Like, I'm really bad at that for some reason, and so even just having that was like, oh, okay, I get it. That's awesome. So, Thank you so much.
Yeah, I think I saw in there too, in that documentation, it included a little blurb on adding the MCP server to Copilot, right? So that in your chat to Copilot, it could use that as well.
Yeah, you got to give it the context. So
yeah. So that's very cool.
Cool. Well, you guys, thank you so much for your time. This was fun, and I think that any last piece of advice before people walk in and start hacking the morning of the event.
Well, one thing I would mention, I think we've talked about it a little bit, but the code that we've shown here, we're hoping we're going to have it just available in a GitHub repository. I think we have it in the notes. I'm not sure if everything's been uploaded yet, but it will be. As just kind of a way to get started, can be used as examples or as is if it fits. So the kind of the intention of this is to provide just some things that we know work with the data and things we expect might be useful. And so we'll be making them available in the GitHub repository so that anyone can use them if they want to.
Yeah, so I mean, so helpful. Like you want to spend as much time as you can being creative and planning, in as little time troubleshooting as possible in a hackathon. So.
Yeah, and I would say understand your data. So last time I have seen a lot of difficulties in understanding the data, and then see what you're trying to build out, right? So that's one thing what I would say, and the next thing is make use of all the tools and latest AI tools that's available, like Napkin AI and other things, like where you can draw your diagrams and things like that. So try to use the tool before you jump in and then write your own code or develop your code. So that's what I would say.
Yeah, for me, I would just say, I'm going to be there during the hackathon. I think, Alex, you're going to be there, right?
Mm-hmm. I'll be in Chicago and you'll be in Mountain View, is that right?
Yeah. Definitely don't be afraid to come up and ask for help if you need it, especially if something's blocking you. But yeah, we're just here to be resources, and definitely don't be afraid to utilize us.
Awesome. Thanks so much. I can't wait to see the cool stuff people are going to build. Take care.
Thank you.
Thanks, Evan.
Bye.